Spartan fans, are you ready for some vector applications? I hope so. Calculator and book. We are going to look at page 607, number 78. Finding the speed and direction of an aircraft. An Airbus A320 jet maintains a constant speed of 500 miles per hour headed due west. The jet stream is 100 miles per hour in the southeasterly direction. We're going to find the velocity of the air and the velocity of the jet stream and the velocity relative to the ground. And we're going to look at speed and direction of the A320 relative to the ground. Okay, so before we get started, let's look at what the velocity vector looks like. So a velocity vector is speed and direction. And the force vector is the amount of force and direction. So notice they both involve direction. How fast are you going, in what direction, and how much force is being applied to the, whatever it is, the box, the car, or whatever. And they both have direction. Regardless, this is going to be the vector. It's going to be the magnitude. Remember, magnitude is length. Cosine of theta I plus sine of theta j. So whether it's velocity or force, it's the same formula, so to speak. Magnitude, cosine I, sine j. All right, so for this particular problem, we have the plane is going due west. How fast? 500 miles an hour. Okay, and then jet stream is 100 miles per hour in the southeasterly direction. Okay, so here's south. Easterly is here. So southeasterly is going to be as such. And we are indeed going to assume that this is a 45-degree angle. Definitely you're going to make that assumption. The velocity of the air, not the velocity of the air, no, the velocity of the jet relative to the air. Okay, so they have us noting that with V sub A. So this is going to be 500. That's how fast the plane is going. I cosine theta plus j. 500 comes from how fast the plane is going. All right, so we're going to assume this is 180. 180. So the cosine is -1. This is going to be negative I, and then the sine is 0. So this is going to end up being negative 500 I. Okay, let's look at the next part, which is the velocity of the jet stream. So they have this labeled V sub W. So that's going to be 100. All right, so all around here, 315. So this is going to be I times the cosine of 315 plus j times the sine of 315. All right, so this is going to be cosine of 315 is root 2 over 2. This is going to be I root 2 over 2 minus, because the sine of 315 is negative root 2 over 2. I'm using my erasable pens, which don't show up as dark, but I don't trust that I'm not going to make a mistake and have to pull out the white out later. Okay. Going to distribute, so this is going to be 50 root 2i. Someone write it as 50i root 2 minus 50j root 2. That's the velocity of the wind or whatever it is we're looking at. Okay, the next part asks us to find the velocity relative to the ground. Okay, so for the velocity relative to the ground, I'm going to add the two of them together. The velocity relative to the ground is going to be the velocity of the airstream plus the velocity of the jet stream plus the velocity of the airplane plus the velocity of the jet stream is going to give me the velocity relative to the ground. All right, so the velocity here, that's going to be negative 500i plus 50i root 2 minus 50j root 2. So now I'm going to look at the speed. So let's take a look at the speed. Okay. So the magnitude of the vector let me rewrite this a little bit better. Good thing I used my erasable pens. I'm going to factor out the I, and it's going to make it easier to plug into our calculators in a minute. This is negative 500 plus 50 root 2, that's my I, minus 50, and then the j root 2. I'm just rewriting it because now when I want to plug in, right, using my, this is like my x and my y, my coefficient on I and my coefficient on j, I can find the magnitude of the velocity. Magnitude of the velocity vector. Okay, so this is going to be how about negative 500 plus 50 root 2 squared plus negative 50 root 2 squared. Okay. And I went ahead and did the problem ahead of time. If you plug this all into your calculator, you should get about 435 miles per hour. So if you think about this, the plane is going 500 miles an hour, but it has a jet stream like pushing on the plane, like, you know, yeah, up against the plane, I guess you could say, moving southeasterly. So it's a headwind. it's a headwind, so you're going slower. If it was a tailwind that was going in the whatever, headed west somehow, then the plane would be going faster. So the plane relative to the jet stream is not going 500 miles an hour. It's really going 435 miles an hour. Oh, and we want to know the direction. Okay, so it's direction to the ground. So sine over cosine, let's use tangent. You could, if you wanted to, you could use like this number is your hypotenuse, whatever. I don't recommend it. I'd recommend that we just stick with tangent. So tangent is sine over cosine. So my sine is my j coordinate, which is negative 50 root 2. Sine is the j coordinate, and in this case right here, our j coordinate is negative 50 root 2. Our cosine coordinate, this is one of the reasons why I rewrote it, 50 root 2 minus 500. All right, so plug into your calculator again. I did it ahead of time. Okay. So if your theta, excuse me, you're going west and then you're being pushed in a southeasterly direction. So this is right here, 9.4 degrees. Okay. So there's several ways that you can write that. This ends up being 80.6 degrees. So you're headed south of west. You're headed south of west. Okay, so here's west and you're going south from the westerly direction. And that is going to be 80.6 degrees. South is a full 90 degrees. From west to south is a full 90 degrees. So this is why we're going to use the 80.6. South to west, 80.6. The directions, like southeast, north, etc., sometimes they can be confusing. I'm not going to be picky about, did you know that was southwest? Is it west south? And the 9.4 degrees and then the 80.6 degrees are the most important. Let's look at number 82. Doesn't require much room, so I'm just going to use this piece of paper still. Number 82. Okay, that says the weight of a car. Magnitude, remember magnitude is the length of the vector, of 1,200 pounds of force is required to prevent a car from rolling down a hill whose incline is 15 degrees to the horizontal. Okay, so what number are we doing? So I have my horizontal, 15 degrees for my car. Here's my itty bitty little car. Okay. So I cracked myself up. The magnitude of 1,200 pounds is required to prevent a car. Okay, so there's two things going on here. There's gravity and there is the force of the car. Gravity is pushing down on the ramp. Gravity, or think of it as Let's say that my gravity is some magnitude, right? Some gravity. That doesn't make any sense, sorry. Like the vector representing gravity, the magnitude. And then the force of the car, I'm going to say that is, remember that means magnitude, the length of the vector. Okay. Well, I have an F1 and I have an F2 and I have this angle here. So it'd be very helpful if I could label my picture. So gravity is what's going to be pushing the car backwards. Gravity is what's pushing the car backwards. And then I need a force, what was it, 1200? The 1200 pounds is the force required to keep the ramp up before gravity sets in. So picture that you have a car on a ramp and the car's not going to roll down automatically, but it's certainly essentially once you get to a certain point, gravity is going to take control depending on how much the car weighs. So the 1200 represents the force required to hold up the ramp, so to speak. So this is going to be the sine of 15 is equal to, I should label, this is F1 and this is F2. You should put your bars. I get lazy. You should put them in. So this is going to be the force of the car, the magnitude of the force of the car, and over gravity. So this is going to be the sine of 15 degrees is equal to 1200 over F sub 1 and you solve and you end up with 4,636 pounds. Let's take a look at number 94. Hopefully you'll find that the problems in the homework are similar to the problems that I'm doing in the video, so you can refer back. And there's also some really good diagrams in the textbook, since we all know that drawing is not my strong suit. You'll find some really good pictures to help out, hopefully, if you're having a hard time visualizing what's going on, which we've talked about before is really hard for me, so I understand. Two muscles exert force on a bone at the same point. The first muscle exerts a force of 800 N. I don't know what that means. I don't know what the N stands for. At a 10-degree angle. The second muscle exerts a force of 710 N at a 35-degree angle with the bone. What are the direction and magnitude of the resulting force on the bone? Okay, so we'll try and draw a little bit of a picture. See how I do here. Let's start with, we have 10 degrees and it's a force of 800. Here's my bone. And we're just going to, of course, it's nice, we can just assume that we have the horizontal. Okay, so it's 10 degrees and the force is 800. And we'll just call that force 1. I feel like I'm in a Star Wars movie, force 1. Anyway, and then the next one is 710 at an angle of 35 degrees. So between now and when you see this video, I will look up what N means. And our force here is how much? 710. Okay, so the resulting force is going to be what happens when you add the two together. So what should we say? Total force, maybe? Resulting force. I got to think of a letter for that. Resulting force. What would you say, F3? That's going to be equal to the first force plus the second force. Okay, so let's write some vectors. For the first one, F1, that is going to be 800 cosine of 10 degrees I plus the sine of 10 degrees J. And the force of the second vector is equal to 710 the cosine of 35 degrees I plus so cosine of 35I plus the sine of 35J. All right, so the resulting vector is going to be what happens when I add these two together partially. So let's factor out the I. So this is going to be I 800 cosine of 10 plus 710 cosine of 35. I skipped some steps here. Distribute, take out the I. And then I am out of room. Same thing with the J. So the J is going to be 800 times the sine of 10 plus 710 times the sine of 35. All right, so to find the length of the resulting vector, F3, I'm going to require some space here. It's going to be the square root of approximately on my calculator. This first is 1,369.4. So I need to square that. Plus 46.16 squared. So essentially we're using the Pythagorean theorem. $1,474 N. And then the angle measure. So this is the first part. So I'm going to do the tangent. Is going to be my sine over my cosine. So my J component over my I component. So the J component, which luckily I saved in my calculator. Remember, tangent is the sine over the cosine. So I'm using the sine component, the J component sine, and the cosine is the I component. .7 degrees.